Hello, everybody. Welcome to McDonald Observatory. Welcome to the Texas Science Festival, and welcome to our program that we're calling The Stars at Night Are Big and Bright because we're out here in West Texas. My name is Judy Meyer, and my colleague Joe Wheelock is sitting in the dark just over there. Joe is in the telescope dome, and he's going to be showing us live views from his telescope, and I'm going to be talking about them. So let me just add our slides in here so we can see them. So this is our deep sky tour. We're part of the Texas Science Festival this year. We're really glad that you're here looking at what we're doing. And if you are joining us for the first time, go ahead and mention that in the chat. If you're joining us from somewhere in Texas, you can put that into the chat. If you are joining us from somewhere other than Texas, you're welcome to put that into the chat too. We have moderators on hand. Our moderators want to answer your questions. So if you have any kind of just general astronomy questions, our moderators would love to answer those. If you have questions that are specifically for me or Joe, our moderators can pass them over to us. But I'm seeing lots of folks from places in Texas, and then some places from other places as well. So feel free to chat. That's what we're here for. That's why we're doing this live. While we're waiting for, Joe's got an issue going on. All I'm seeing on his feed is the top of his head. I'll tell you about myself. My name is Judy Meyer, and I live and work here at McDonald Observatory. And I am part of the program staff, which means I get to do programs with people like you who come to visit. And I get to, I'm also part of the K-12 education staff. So that means sometimes I get to talk to students and teachers and people like that. And it, like Supernova McDonald says, it's great to have everyone here tonight. So what we're going to be doing is looking at some of our favorite things in space and our favorite things that are visible in tonight's sky. So we'll talk a little more about those after a while, but let me just show you some pictures. Here is a beautiful, beautiful view of McDonald Observatory. And our beautiful view of McDonald Observatory taken at the evening. This is not taken today, but it shows on the right-hand mountain, Mount Locke, our two telescope domes, the 107-inch dome on the left and the 82-inch dome on the right. And then on Mount Folks on the left, you can see the shiny silver dome that houses our largest telescope, and that's our Hobby Eberly telescope. In between those mountains, just at the base of those mountains, is there's some housing and our visitor center, and the buildings that you see closer to the front of this picture are a local ranch that's nearby. And so that's not part of McDonald Observatory, but they have a nice view too. So let me show you. Here is our visitor center. And from our visitor center, if you come to visit us, you'll see our visitor center, and you can look at from the visitor center and look up and see Mount Locke with its telescope domes. And it's a very beautiful evening tonight. We had a weather forecast that did not look so great. Yesterday at this time, our weather forecast was for damaging winds and dust storms. And our wind has died down a little bit. So we have opened up our telescope, and we don't have a strong dust storm going on. So we're very happy to have that. And we're very happy to have all of you here. Let's see, what else do I want to show you? If you walked around to the backside of the visitor center, or if you were to take your helicopter and fly to the backside of the visitor center, you might get a view that looks like this. It would look like this except for the orange arrow in there. And the orange arrow is pointing at the dome where my colleague Joe Wheelock is sitting. And Joe is, I don't know, fighting a technical issue. I keep seeing, oh, there he is. And
It's
Joe's
fixed.
in the dark. It's fixed. Yay. So Joe's inside that dome. The dome is open. The sky is getting darker. And Joe is going to show us some of the very cool things that we can see in the nighttime sky. So Joe, do you want to say anything about what it is you do here at McDonald Observatory? How long you've been here? That kind of thing?
Man, I've been here forever.
He's been here forever.
Yeah, just about a couple years longer than you. I do public programs, help with the star parties, and did a lot of stuff behind the scenes, and pretty much kind of maybe I guess you could say to I guess this is kind of a maybe kind of a jack of all trades, maybe I don't know.
Yep, and we count on Joe for lots of our answers when we have just general questions about stuff, like, just random weird facts, like how many stars are in this star cluster, or how old is this whatever. We ask Joe.
And anything Star Trek related.
And anything Star Trek related, yes. So if you have any questions about Star Trek, Joe's your guy. All right. So I'm seeing a question that says, how old is the universe in years? It's old. Astronomers right now are thinking the universe is about 13.7 billion years old. And somebody else thinks the universe is 15.5 billion years old. So Joe has been here 13.6 billion years. No, Supernova McDonald, you're wrong. Joe has not been here quite that long. Joe, are you ready to talk about our first telescope object?
Yeah, in fact, let me put it up here on the screen.
Let me show you a slide that shows where we're looking. Because what you're seeing is a simulation, and it shows some stars. And maybe you can see a pattern of stars that looks familiar. It's a little hard for me to see. It looks a little dim, and I've got studio lights. But right in the middle of that view, kind of in the lower part of the view, we have the pattern of stars that we call Orion. And that's Orion in mythology is a hunter, and in other people's mythologies, Orion could be something else, a king, whatever. But it's easier to see the pattern of stars if we play dot to dot with the stars and connect the stars with lines. So I'm going to do that, just add in some lines. But it turns out, and here's Orion, you can also use software to get pictures. So those pictures are not out there in space. Neither are the lines, but the pictures are not out there in space. But I want to add the pictures just so you can see how Orion fits in with a hunter. So here is Orion. He's kind of in the middle of our view. He's holding a club over his head. He's got a shield out in front of him, and he's hunting Taurus the bull, who's up and to the right in our view. So that's Orion. And we are going to start by looking at one of our favorite things in Orion. And that favorite thing in Orion is the Orion Nebula. And the Orion Nebula is found in the Sword area of Orion. And a nebula is a fancy word for a cloud of gas, and I probably will say that more than one time. But I think my next picture shows a huge cloud of gas that takes in most of Orion, and it's called the Orion Molecular Cloud. Ooh, and my slide went away. So let me get my slide back. Uh-oh, I wonder where my slide went. It went away, and I will get it. Oh, here it is. Now let me just move over one slide there. So we just added in some of the Orion Molecular Cloud. It's a cloud of hydrogen, so it glows red. And this was a picture taken by a person. And we can zoom in on that. Oh, that's not going to do. I really wanted that to stay on my screen. So we can zoom in on that molecular cloud, and we can see the pieces of Orion that are familiar to us. The 3 stars across the middle, that's the belt of Orion. The bright star in the upper left, the reddish looking star, that's the star Betelgeuse. And the star in the lower right, the bluish looking star, that's the star Rigel. And the Orion Nebula is just below the belt, kind of that pinkish whitish area below the belt of Orion. So now I think what we should do is go to the telescope view. Are you ready with the telescope view, Joe?
Yes, I am.
Excellent.
Here we go.
Let's add that in, and I will take this out.
Right here. There it is.
There you go. Whoa, look at that. That's so beautiful. So Joe's using our color camera tonight, obviously. And what we're seeing is we're seeing some bright stars because Orion is, the Orion Nebula is a cloudy region where stars are forming. Those stars are very young. And then we're seeing that cloud, and the cloud is glowing. And the cloud is glowing pink because it's mostly hydrogen. What do you like to tell people about the Orion Nebula, Joe, when you look at it?
I like to tell people that you could say it's like a stellar nursery where there are baby stars. Now, because of the longer exposure I'm using, we cannot see the stars at the center of it, which are young stars called the trapezium.
Yeah, it's just kind of a big glowy blob.
Right, yeah.
Is there a way to decrease the exposure for?
Yeah, give me a second here, and I can do that. Okay. So just let me remove my picture of the nebula, and I'll fiddle with it behind the scenes here.
It turns out that tonight we're just looking at nebulas. And like I said before, nebulas are clouds of gas, and this is a cloud of gas where stars are forming. So I don't know what Joe's doing. What are you doing, Joe?
Sorry, let me check out. So I may decrease the exposure. Stand by.
Okay, thanks. I'm just gonna stick the telescope feed back into the stream so we can watch you work. So we decreased the exposure a little bit, and now the view is dimmer because we're adding the light for less of a long time. Is that what I mean? I think that's is. There it is again. But right in the center where it's very, very bright, when we look at Orion with our eyes, with a telescope, we see 4 stars in a tiny little square, and that's the Orion Nebula. Marie says, I think Orion was created when a bunch of drunken Greeks looked at the sky and saw a man. Maybe, you know, if you don't know that your water is good, you have to drink wine. And then what is there to do if you don't have TV but sit outside and tell stories and find a figure of a man? Okay, now we're almost seeing all 4 stars of the trapezium. The other thing that confuses people when they look into the eyepiece to see Orion is those 3 stars in a row that are above the bright core of the nebula. And often I hear people say, oh, I see the belt of Orion. No, we are focused in on the middle star of the Sword of Orion. And the middle star of the Sword of Orion includes the cloud and the stars and those 3 stars in a row. So there's lots of stuff going on in there. Now we're kind of seeing the trapezium. It's very nice. Oh, what is the smallest and largest thing in the universe? Oh my goodness, Joe. Do you know the answer to that?
What's the question?
What is the smallest and largest thing in the universe?
Smallest thing, I guess technically you could say it could be you have subatomic particles, like, quarks and things like that. Largest thing, I guess you could say, are huge galaxy clusters.
Huge galaxy clusters, or the universe itself.
Or the universe itself.
The universe itself is the largest thing in the universe.
Right.
Yeah. That's kind of what I would say too. The smallest thing is a subatomic particle, so smaller than an atom, and the largest thing is the universe. I bet you we're looking for the largest single thing, and I don't know. So Joe, what else can we do with the light to get a cool view of Orion?
I mean, if I increase the exposure too much, it'll wash out. It will, burn out the stars like the trapezium. And Orion, it's really bright. You don't need a really long exposure to get a good picture of it. And it's a really beautiful object in a telescope, too.
It is.
In fact, depending on your vision, you may see some color in it. The camera we're using is a color camera. Your eyes don't detect color well in low light levels.
Mm-hmm.
So the color cameras can bring out some of the all the details.
The other thing that I've noticed from star parties is that the younger your eyes are, the better they are at seeing the color.
Exactly.
Yeah. So, do you want to see a few more slides about the Orion Nebula? Or are we ready to leave it and do something else, or? I don't know what we're doing. Can you brighten that up a little bit, Joe?
Oh, yeah, definitely. Yeah, hold on.
Let's do that. One of the things that I like about looking at Orion is I think it looks kind of like a big, and I'm kind of a romantic, I guess, a big fluffy flower. And so I will show people, help people look in the telescope and see this. And I really want them to say, oh, it looks like a big fluffy flower or a fancy fluffy ball gown, or something fluffy and pink and pretty. And I get kids who come and look in the telescope and say, it looks like a squid, or it looks like a bug, or something like that. And it's just like looking at clouds. Every different person sees clouds in a slightly different way. Well, I want to share a couple more slides from here. So I'm going to just take over the stream here. And here we are looking at the Orion molecular cloud, and the nebula is this pinkish area below the belt. We're going to come back to this molecular cloud later on in our program. But here's a picture from the Hubble Space Telescope of the Orion Nebula. And I love, love, love this picture. I feel like it looks like a Renaissance painting or something. Those stars of the trapezium are right in that bright middle part. You can see some cool dust looking darker. And this is at a different orientation than what we had with our regular telescope. And then scientists have been thinking about what shape this thing is. Take a big cloud of gases, form stars inside it by letting those gases condense. And once there are stars, the stars have radiation pressure that kind of pops this cloud open. So they're thinking the cloud, what we see is kind of like a bubble that's popped open, or a bowl with some cloudiness on top of it. So here comes I don't think I have another slide yet. So here comes a fly through. This is a simulation. We're just going to fly through the Andromeda, the Orion Nebula. So we're flying past some blue clouds. And see how it's kind of dish-shaped with a few fingers of clouds sticking over the top? Just going to fly in and see some brand new stars. Now, we say these stars are young. These stars are as young as a few million years old, but stars are still forming inside this nebula, inside this cloud of gas. We're also noticing that some of the stars have disks of material forming around them. So some of the stars are showing planetary formation. So that was our fly through of the Orion Nebula. And now, back to my slides. I got this one. Joe is moving I hear that. So here is just a single shot of that fly through. Here's a picture of the Orion Nebula that our colleague Stephen Hummel made, and he used the telescope that Joe's using. But if you were allowed to take a longer exposure photograph, or maybe take a series of photographs and stack them and play with the colors, you can get those colors and those details to come out. So I wanted to share this picture from Stephen as well to to show you what kinds of pictures we can make with our telescopes. It takes most of a night to take this kind of picture, but there you go. Who came up with the name Orion? I'm sure it was ancient Greeks and Romans in their mythology. All right. I'm going to move on. If Joe has moved the telescope, let's go to another part of the sky. So we were in Orion. Orion is down near the lower part of the screen here now. And just above Orion is a constellation of Gemini. And Gemini, in mythology, it's a figure of twins. So it has two bright stars up near the top of Gemini. And then I like to think of this. Oh, are we doing this one, Joe?
What's up?
I'm giving the map to M35. I'll bet we're not doing it though.
Did we just? We can if we want.
Not to. I think we decided not to. We're going to go to the next thing.
This nebula.
I will talk about it, but Joe will go to the next thing after this. That's what we'll do because I can't change my slides and I can't skip. All right. So we had thought we would show you this, but we're not going to. I'll just show you pictures. Right here at the toe of Gemini is a cluster of very young stars. And that cluster of very young stars, we usually call it by its catalog name. And its catalog name is Messier 35. We use the Charles Messier catalog of things that you can see with a telescope that are not comets. He was a comet hunter back in the 1700s, and he kept finding things that weren't comets. So he found this number 35 on his list, and number 35 is this very nice cluster of very young stars. Now, when I say young, I know they're older than the stars in the Orion Nebula because all that cloudiness has been used up and turned into stars. So these stars have an age of about 175 million years. The cluster itself is about twice as far away as the Orion Nebula. And it's a big clump of stars. They all form from one of those big clouds. And so there they all are in one place. And that's Messier 35. But it turns out if your telescope's good enough, you can zoom and see right next to Messier 35, this little tight cluster to the lower right of it. And that is a cluster that doesn't have a cute name. It's NGC 2158. So 2 clusters for the price of 1. And we're not going to go there with our telescope. It's something that's pretty easy to see with a telescope. And we are concentrating tonight on nebulas because that's what we like. Somebody asked if Stephen Hummel is still working here, and yes, he is. Stephen is the dark sky specialist for the observatory. And so he spends a lot of time out and about talking to people about their lighting. But we really appreciate his work using the telescopes and looking at things. All right, so we're still at Gemini, and instead of one of the twins' feet, we're at the other twin's elbow now, and we are going to look at a cloud of gas. And this is a cloud of gas that is left over after a star that started like the sun ran out of fuel. And I only have one slide for this, Joe. So whenever you're ready, I'd love to show it. And if you're not ready,
hold on.
Okay. If you're not ready, I'll talk about how stars run out of fuel.
I'm ready. I just had something funny happen here.
Joe had something funny happen here. Well, while we're waiting, let me answer a question. Marie asked, isn't dark matter only theoretical? Well, dark matter is matter that we have not detected using our normal ways of detecting things. However, galaxies appear to have more mass in certain places in the galaxy than would be explained by things that we can measure. And so we're using our science brains to figure out that there's something else there. And right now we're calling it dark matter. I don't think you can. And so it is a theory, but a scientific theory means it's it's a thing, but it's a scientific theory right now. We haven't figured out how to directly detect it. And then Kaushik Kelkar says, how do we know how old stars are? That is a hard problem, actually, to know how old stars are. But we've looked at enough stars that we know that stars start out young and kind of bright and sparkly and blue. And as they get older, they burn through their fuel. And as they get older, they cool off a little bit, and they may grow or shrink. They may change in brightness. And we've looked at enough stars that we have a pretty good idea how old stars are. So what we're going to look at next is is what's left over after a star that started like the sun ran out of fuel. So stars, are you ready, Joe, to show that?
Yes, just about.
Oh, just about.
Give me about 16 seconds.
Our sun is not going to explode. So in a star like the sun right now is at what we call hydrostatic equilibrium. That means the gravity pulling in is equal to the energy pushing out. So the sun is in balance. But at some point, the sun is going to run out of hydrogen fuel, and its outer atmosphere will puff up, and its inner core will collapse down. And at some point, the sun will kind of belch layers of material, but it will not explode. You have to have a much more massive star to explode.
Ready, Judy.
Is a low mass star. What?
I'm ready.
Go ahead. Let's see it.
Go. Oops, it helps if I click add to stream.
Add to stream. There you go. Okay, so what we're looking at is that blue bubble. And that is a nebula. And that nebula does, we often call it by its catalog number. So that's NGC 2392. And it has a lot of nicknames. And Joe, is there a way to zoom in on that?
Oh, yes. Hold on a minute. I can do that.
Because I think it'll make the nicknames make more sense.
Right. Give me a minute here.
With a little more magnification.
I will do some magic. Oops, that's too much magic.
Well, that's there. That's good. So what we can see is that in the center, there's a little bright star, and then kind of a shell of gases, and then more gases out beyond it. So this nebula has a bunch of different nicknames. And some nicknames are lion, because it looks like a lion's mane. For a while, people thought it looked like somebody was wearing a fur parka. So the hood of a fur parka, and that central part looks a little bit like a face. And but right now we're calling it the dandelion, because it's a little bit like a lion and a little bit like a dandelion. So that's our dandelion nebula, NGC 2392.
And that's a satellite that passed across.
Oh, that's what that diagonal line was, a satellite?
Yeah, satellite. Those
can you tell how excited we are about satellites, folks? Not so excited. Satellites kind of mess with our view. Fortunately, we're not trying to do science with this view. But wow, I am seeing so many questions go by, and a lot of them, wow, it's probably more than our moderators can do, but we'll do our best. Do we have any tools to, I'm just going to answer this one. Do we have any tools to explode stars? The answer is no, we do not. Okay, so no, we do not. What else can we answer really fast? I don't know. How do stars disperse after forming into a nebula? So this is a nebula that's left over after one star died. So there's no stars to disperse. There's just one stellar core in the middle, and that's it. Sometimes stars collapse into larger stars or start to orbit each other. Often when stars are formed, they start to orbit each other. Let me see if I can get this. Yeah, there. But not usually after they've already been stars. Okay, so that is our Dandelion Nebula, and I think it's beautiful. Oh, yeah. Anyway, so I want to show you a picture from the Hubble Space Telescope of the Dandelion Nebula, and so I'm going to put that in my up here so you can see it while Joe goes to the next target. And there it is. This picture was taken in 1999, right after Hubble completed a servicing mission. Oh, so we're having, so what you can see is that you can see this kind of up close and personal. I think this is a wonderful view. The central star is the collapsed core of a star that started out like the sun. That middle part that kind of looks like bubbles that are full of, like balloons full of gravel or something. They're sort of lumpy bubbles. We think that's two bubbles that are about a light year long and about half a light year across, and they're kind of end to end. It's hard to see the three-dimensional shape of this thing, but we think that this star, as it was dying, had an extra amount of stuff around its equator, and so it bubbled up and down more than it bubbled out, and then gases escaped, perhaps at different rates, to show you the lion's mane section out beyond our bubbles. So that's our Dandelion Nebula, and I think it's just very beautiful. What do the letters and numbers in a star's name mean? You know, there are, I'm just going to show this. This is user 4. There are, stars are cataloged in many, many different ways. And there are many different stellar catalogs. And so it's just like a phone number. In fact, when you talk to research astronomers, they will call the star's name its phone number. And it might be HD24796. So it sounds like a phone number. And we do the same thing. We're not usually looking at individual stars, but we're usually looking at things that are like, that are made of stars, or things like nebulae like this, or star clusters, or, you know, things that are interesting. Those things have catalogs too, but that would be a different catalog. So you have one list of regular stars, one list of exploded stars, one list of dead stars that started like the sun, stuff like that. So that's how the catalogs come. And it gets very complicated, and most stars, single stars, have more than one catalog number. How far away is the Dandelion? It is, I wrote it down because I wouldn't remember, and I didn't write it down. Joe, do you know how far away the Dandelion is?
It's about 3,000 light years away.
Thank you. Very good. It was discovered by William Herschel in 1787. What's our next target, Joe?
The Crab Nebula. I'm working on it.
Okay. Well, I will talk about where to go to find it. So we're back to our star map, and you see Gemini in the middle and Orion at the bottom, and over to the right, there is Taurus the Bull. And Taurus the Bull starts with this little V-shaped group of stars, and the bright star in the V-shaped group is a bright star named Aldebaran. And then Taurus is a bull, and this is a Texas program. Taurus is a longhorn, but the horns go straight up. And just off the tip of one horn, we find this this thing that we call the Crab Nebula. Now, remember I said a nebula is a cloud of gas in space. And we've seen a nebula that's a cloud of gas in space where stars are forming. And we've seen a nebula that's a cloud of gas in space where a star has died. And now we're going to see a nebula that's a cloud of gas in space that a star exploded. So a very massive star doesn't die like the Dandelion did. Instead, it explodes, and that's a supernova. And the cool thing about this nebula is that people observed the exploding star. They saw it in the sky in the year 1054. And in the year 1054, there were people already recording things that they observed in the sky. And so Chinese and Japanese astronomers have left records about seeing what they thought was a new star in the sky. And that new star, it suddenly looked bright because it was a star exploding. And then later on, folks looked at that area of the sky and found this cloud that we call the Crab Nebula. The Crab Nebula is, what else do I want to say? It looks way different from the dandelion. Let's see, here's another. Would you travel? Oh, I am going to, I don't have it close to put it up on the screen, but the question was, would you travel out to another star system if you could? Would I watch a lot of Star Trek. It makes me think I could, but I don't want to. I really kind of like our solar system, so I think I'll stay here. I'm seeing a question from Genesis 1A. It says, how long does it take? How many years does it take for a black hole to die out? We don't know. We haven't ever seen one die out. What happens to the contents of galaxies when two of them collide? I'm just grabbing questions. When two galaxies collide, here's the deal. Galaxies are really big, but inside a galaxy, the space between the stars is extremely vast. And so when galaxies collide, usually stars do not collide. Usually, stars miss each other and go past each other, but the gravity from one galaxy feels the gravity from the other galaxy, and so stars might stream around. The galaxies end up coalescing into one big ugly galaxy when they collide. All right, Joe, are you ready?
Yes, I am.
Yay! Let's look at the Crab Nebula.
Let's find it.
Oh, I know it's there. Yes, Elsa, I think you're right. Earth rules. There it is. So the Crab Nebula is a cloud of gas where a star has exploded. And Joe, can you magnify that a little?
Yes, one
Okay,
minute.
we're seeing some colors.
That's too much.
So when we look at this, I'm really happy to have a camera view of this. When we look at this with our eye in a telescope, our telescopes aren't big enough to collect enough light to get a bright view like this. And so it's pretty dim. And here we're seeing this cloud. And I think that's great. We can also see some sort of filaments in there. Uh-oh, where'd it go? It's your screensaver, Joe.
Uh-oh, hold on.
Oh, there you go. So we can also see some filaments in there. And what do I want to say about the Crab Nebula? It's great. Inside the Crab Nebula, it's not a white dwarf star, a little tiny star like what was inside the dandelion. Inside this one, there's not a black hole. Sometimes if a star that goes supernova is large enough, it can make a black hole at the end. This one created a pulsar. So there's a crab pulsar in the center of it. It's a very tiny, extremely dense item that's spinning really fast and sending out pulsations. So that's the Crab Nebula. I love the story of the Crab Nebula. I love that people were able to see this new star in the sky back in 1054. And they first noticed it on the 4th of July, which I think is kind of, I don't know, kind of cool, kind of weird. Anyway, shall we talk about the next thing? I'm ready.
Okay.
Okay, so I'm going to put my slides back in here, and then I want to show you an image from the Hubble of the Crab Nebula. And I want to say this image is At the time that it was published, it was the largest composite image ever published by the Hubble. They used 24 individual pictures of the Crab Nebula and put them together. And so it is the most detailed image of the Crab Nebula that the Hubble Space Telescope had published. And it's beautiful, isn't it? I think it reminds me of a loofah sponge. It's got those fibers, and that star was exploding, and it's basically star guts. The Hubble people would like you to know that the colors of this picture have meaning. And I wrote it down, and now I don't see where I wrote it. Maybe I didn't write it. Oh, it was the last one. The colors do have meaning, but I don't know what they are. But on the dandelion, I wrote it down there. Too late. Oh well. But so this is the Crab Nebula at high resolution, and I think that's wonderful. All right. So the next thing we're going to do is go back to the Orion molecular cloud. Ooh. So let's just move over to that. So there's Orion. Let's add in the molecular cloud, and we're going to go to the end of the belt this time. And we're going to go take a look at what we call the Horsehead Nebula. And the Horsehead Nebula is something that amateur astronomers, it's kind of a challenge object for amateur astronomers, but it's a nebula. Remember, it's a cloud of gas in space, and the Horsehead is part of this big Orion molecular cloud. There's lots of gas, and so when we look at it, we're going to see gas, and then the horse itself is kind of a dark figure in front of glowing gas. I think I have there we are. So the Horsehead is at the left-hand edge of the belt of Orion, and you can see there's a little bit of extra pink over there. And it's next to the bright star in the belt whose name is Alnitok. And let's see. I think I have one more slide. If I don't, it will be a picture of the Horsehead Nebula. This is a picture of the Horsehead Nebula. And this is a picture that was taken by Stephen Hummel using our equipment. And so what you see is that dark cloud and then glowing sky behind it, and that's why we were able to see it. But I don't want to show that to you very long because I want you to see it live. Are you about, yeah, right next to Alnitok? I think that's wonderful. Somebody says, what would Orion look like after Betelgeuse explodes? We think Betelgeuse is going to go supernova sometime in the next, I don't know, 10,000 years or something. And that will make Orion look different. And so Orion will look like he's missing a shoulder. And that'll be interesting. But while Betelgeuse is exploding, it'll look like Orion has a super bright shoulder. Joe, how are you doing with that? Marie says this looks like a gorilla. I'm not so sure.
Almost getting there.
Okay.
This will take a longer exposure.
Okay, yeah.
Pretty faint.
The problem with observing the Horsehead with a telescope with your eyes is that there's not a whole lot of contrast between the dark thing in the front, the horse, and the bright cloud behind. The bright cloud behind isn't all that bright. So it's hard to see with your eyes and easier to see if you're able to take a longer exposure photograph. And that's why we're going for the longer exposure photograph. Okay, what other questions are we looking at? We're talking about gravity and gas pressure, and oh my goodness. Can you see nebulas with binoculars? Yeah. If you point your binoculars, I will just pop this up here. If you point your binoculars at Orion, look down in the sword, you should probably see some cloudy stuff in the middle of the sword. What other nebulas can we see with binoculars? Moderators, can you help with that? Yeah, since Betelgeuse is about 700 light years away, is it possible it already has exploded and the light hasn't gotten to us yet? Yes, that's possible. But we won't know it. You know, if it explodes today, we won't know it for 700 years. So It sort of means you have to change what you think of as now. Goodness. Genesis 1A, you are asking questions that are beyond the scope of this discussion. How much rings does J1407b have? Joe, do you have any idea? I think that's something that we could look up, or you could look up. And I think since it's not part of what we're talking about tonight, we're not gonna answer that. Not that it's a secret.
Judy, so we have the horse head.
We have the horse head. Let's see it.
Word of warning.
What?
That bright star near the horse head, it can definitely mess with your images.
The bright
so
star.
You're going to see some artifacts from that bright star near it.
Okay.
So let me get it set up here.
So in this picture that's on the screen now, is the bright star you're talking about the one on the far right?
No, it's the one that's in Orion's belt.
Oh, okay. Alnitak. Okay.
Yeah. So let's get this up here.
Yay.
So that's a tricky thing about finding the horse head visually and also sometimes photographing it. But here we go.
Ooh. So that's Alnitak on the right?
Yeah, that kind of
and the thing that looks like
thing.
Rainbows, that's our artifact? Or is Alnitak in the lower right out of the picture?
Yeah. But you can definitely see the horse head shape.
Can you all see the horse head shape? I can. I think it's awesome.
I can.
I love that you can see that the background is red too.
It's a very nice neighbor.
Yeah.
Of course, neighbor, never mind.
Yeah. So what do you think? Can you, okay, Joe, can you stack that a little longer? Is it going to get brighter, or what's going to happen as we watch this?
It will get brighter.
Mm-hmm.
It's stacking as we speak.
Okay. But this artifact in the right-hand side of the screen is very interesting, isn't it?
Yeah, it's something I really can't do anything about.
Yeah, I have always thought the horse head looked like a seahorse.
Yeah.
Yeah. And the discovery of the Horsehead Nebula is credited to a woman named Wilhelmina Fleming, who worked as what they called computers at the Harvard Observatory. And what she was doing was looking at images made on photographic plates and cataloging things. And she cataloged this as a nebula. And so she gets credited with it. We think other people saw it before that, but they may not have seen the horse shape. Somebody called it a horse sometime along the line. But I love that it was cataloged and it's credited to a woman. And I think that's pretty cool. Wilhelmina Fleming worked as an astronomer, but her first job was as the maid to the guy who was in charge of the observatory. And he kept giving her other work to do, besides cleaning the floors, like, hey, can you look at these photographic plates? And she got better and better and better at it. And so she was kind of the boss of all the women who worked at the Harvard Observatory for quite a long while. So this is hers, and I like that. Can you ride this horse? No, you cannot ride this horse. This horse is a dark, cool cloud of gas. Hey, look, we just saw another satellite go by. This horse is a dark, cool cloud of gas. And then the pink behind it is a glowing cloud of hydrogen. That's part of that large Orion molecular cloud complex. Yeah. Park is asking, how long could people see the Crab Nebula explosion in the 9th century? Joe, do you have an idea how long that brightness?
Yeah, it was visible for several months.
Several months. Okay. And then, a supernova, the star brightens and then it dims over time. And now that astronomers can measure that dimming rate and do spectroscopy on the dimming thing, they've learned a lot more about that. Those instruments weren't available in 1054. And so, people said, hey, bright star, and then, hey, bright star, not so bright. I guess it's gone now.
Is that another satellite?
That's another satellite.
Wow. Okay.
Yep. Yeah. Are stars in the Horsehead Nebula? I think, Donella, I think what you're asking is, are there stars inside that cloud? And I'm going to show you another picture of that cloud here in a little bit. And I think there are maybe some, but this is a cool cloud. And so it's not I don't think it's a very active star formation place, but it is. Oh, good. You're finally seeing the Horsehead in it. But so I don't know. One of the moderators, do you know, are there clouds in there? Are there stars inside this cloud?
I think there's one illuminating. That's what's illuminating the Horsehead itself.
It's not illuminating, did?
Perhaps.
I don't know. Hey, let me quick go to my next slide. So there are stars inside this cloud because there's this one. This is a view from the Hubble, and it's showing kind of bubbliness, and I think that's very interesting. But it's made the Horsehead not so dark compared to the background. And it's a very odd view, isn't it? So this is one of the newer views of the Horsehead. I'm gonna put our live view back. Or Joe, can you put our live view back in? I don't see.
Yeah, hold on a second. I'm changing the exposure time to see if we can get rid of that artifact.
Okay.
I'm just lowering the exposure a bit
and
seeing if that helps. So the image may be a bit dimmer, but it may get rid of that annoying artifact. Give me a second here.
Oh, so hanging with the bells, you asked what the rainbow of colors on the far right, and that was an artifact. That was the camera is not as good as our eyes are at seeing both things that are bright and things that are dark at the same time. So there was a bright star right next to where those rainbow colors were, and the camera did that to kind of make up for it. And you have to work hard to make stuff like that go away. So that's why we saw those little rainbows on the right. It's not a real thing. It's kind of like, I don't know, kind of like a lens flare or something when you're taking a picture looking the wrong direction.
Okay, here's a shorter exposure.
Okay.
So the Horsehead won't be as prominent, but the artifact doesn't look quite as bad.
Okay.
So
let's see it.
Let's see how it looks here. Yeah, share that.
Boy, that is a shorter exposure.
I know. That's what I said.
Here, let me. I'm gonna make me go away for a second. The problem is when I go away, I can't talk to you all. So when I go away, the screen goes darker. There's still not much contrast. I like it better with more contrast and the rainbows. I still see little arcs over on the right as well, Joe.
Yeah. It's just, you just can't help it because of that.
Right.
Annoying star nearby.
Yeah, because there's a bright star over there. Well, I think that's just how it goes.
Yeah.
Those are our favorite nebulas tonight. And I've enjoyed showing them to you and sharing them with you all. And I've got one more slide or maybe two. So, it's the ending slide. So we'd like to thank you all for joining us today, and we're happy to stay on and answer questions for a while. But right now, we're just showing you this end slide so you can find us online in different ways: McDonaldObservatory.org, Stardate.org, Friends of McDonald Observatory. We are doing another Texas Science Festival program on March 4th. It's happening during the day, and it is all about eclipses, because eclipses are coming to Texas. So we're going to throw some questions up and answer them as fast as we can. Joe, are you ready to answer some questions?
Why not?
Why not? Wow, SUP12364 really wants the smallest and largest things in the universe. And I think we already answered that. Let's see, what else do we have? I'm going to just go back in time. Does the horse head look like a mushroom? Yes. Or a jellyfish, or a hammer, or a dark fantasy. Other questions? Seems like a model of... Okay. So one of the things that we do is we look at constellations, and constellations are patterns of stars in the sky. And Stephen says it seems like you model the movement of objects that make up constellations. How long before they're no longer familiar? And sometimes we use our modeling software to move time forward and backward, and we can see the constellations changing a little bit, but our modeling software doesn't say this star is going to explode. And I don't know. I think you'd notice a change after a few thousand years. What do you think, Joe?
Yeah, it would take a few thousand years. The Big Dipper, for instance, in about 50,000 years.
In about 50,000 years?
Yeah, it won't really look like a dipper.
Okay.
Now, it depends on some, that's because the stars have proper motion. Some stars move toward us, some move away from us at different speeds. So stars are moving, but very slowly. For human lifetimes, it's something you're not going to notice. Your grandchildren and your great grandchildren will pretty much see the same constellations that we do.
Yep. And I think that's why the constellations that we use don't look much different than how people saw these patterns of stars a few thousand years ago when they were telling the stories that go with Greek and Roman mythology and other kinds of mythology. Tell us about, here's one, I can answer this. Tell us about the star party at the observatory. We do star parties at McDonald Observatory at the Visitor Center. We do them every Tuesday, Friday, and Saturday night. And it's really best, you should come, by the way, and make a reservation because our star parties do sell out. The picture behind me is a picture of the Constellation Tour portion of the star party, where we sit out in our outdoor amphitheater, look up at the sky and talk about the constellations. And then we'll have telescopes set up back where Joe is working and point the telescopes at different things. The telescopes will be set up with eyepieces and you'll get to look at all the cool things. So there we go. Let's see. What other question do we want to answer? I don't know. How often are new nebulas discovered? Mason, AM. How often are new nebulas discovered? Most discoveries that are made these days are made by automated telescopes that take surveys of the sky, and they probably would not find new nebulas inside the Milky Way, but would find nebulas in other galaxies. So probably not that often, or pretty often, depending. I don't know. The answer really is I don't know. Do you have an answer for that one, Joe?
There was actually an amateur astronomer that discovered a nebula, I think somewhere in Orion. It's been probably, oh God, when was that? Maybe a decade and a half ago. I don't know. Maybe 20 years ago.
Yeah.
And I remember the nickname that his name was McNeil, I believe.
Oh, okay.
The nickname McNeil's Nebula.
Cool. Cool. And then there was the Citizen Science Project. It was, I don't remember, there was a citizen science project on Galaxy Zoo where they were having people look at images of space, deep space that had galaxies. And one of the people who was doing this looking saw a thing, and the thing was this green kind of globby cloud. And so they call it Henny's Vorveep, which means Henny's thing. Because they didn't know what it was, but it was this green kind of globby cloud. So that's a nebula. And that was kind of within the last 10 years, 20 years. I don't know. It was a while. And so every now and then, but not super often. How about that? Are there any other questions we want to answer? This has been very fun to talk to you all. Thank you so much for joining us. And I think it's time for us to say goodnight. And we wish you all clear skies and come and visit us. Thank you, Joe.
Good night.
Good night. Bye.